Exercises. Question 1. Fill in the blank. 1. The organic compound having double or triple bonds in them are termed as dash. The answer is the organic compound having double or triple bonds in them are termed as unsaturated hydrocarbons. 2. The general formula of alkenes is dash. The answer is the general formula of alkenes is CnH2n. 3. Dash are known as parent organic compounds. The answer is hydrocarbons are known as parent organic compounds. 4. Covalent compounds are generally soluble in dash solvents. The answer is covalent compounds are generally soluble in organic solvents. 5. Triple bond can be obtained by sharing dash pairs or dash electrons. The answer is triple bond can be obtained by sharing 3 pairs or 6 electrons. 6. Hydrocarbons necessarily contain dash and dash. The answer is hydrocarbons necessarily contain carbon and hydrogen. Question 2. Give the IUPAC name of following compounds. 1. CH3, CH2, CH2OH. The answer is propanol. 2. HCOOH. The answer is methanoic acid. Question 3. Write short notes on first, catenation. Answer. First, the atomic number of carbon is 6 and its electronic configuration is 2,4. Hence, carbon has 4 electrons in its outermost orbit and therefore exhibits tetravalency. Second, in order to attain stability, carbon has to give or take 4 electrons to complete its outermost orbit. However, it is difficult to give or take 4 electrons as large amount of energy is required. Third, therefore, carbon forms bonds by sharing electrons with hydrogen or another carbon atom. Fourth, these bonds are called covalent bonds. Thus, carbon atoms are able to bond with many carbon atoms and give rise to a single large structure or chain. Fifth, property by which the carbon atom form bond with itself to form a large structure as a chain is called catenation. Sixth, numerous compounds are formed in nature due to catenation, and it is a remarkable property of carbon. Second, functional group. Answer. First, when carbon atoms form bonds with carbon and hydrogen, organic compounds known as hydrocarbons are formed. Second, these organic compounds are also known as parent compounds. Third, all organic compounds are considered to be derivatives of these hydrocarbons. Fourth, the derivatives are formed by placing one or more hydrogen atoms by some other atom or group of atoms. These groups of atoms are called functional groups. Example, in methane, that is CH4, if one hydrogen is replaced by OH group, then the compound formed is called methyl alcohol, that is CH3OH. Fifth, the OH group is known as the alcoholic functional group. Sixth, the insertion of a functional group changes the property of the parent compound and gives rise to a new compound. Compounds having OH as functional group are called alcohols. Seventh, examples of some more functional groups are given below. Have a look. 1. The type of compound is aldehydes and they have the general formula RCHO. Its functional group is CHO. 2. Ketones have the general formula RC double bond OR and the functional group is O double bond C. 3. Carboxylic acid has the general formula RCOOH and functional group is COOH. Hydrocarbons having the same functional group form a homologous series. Third, homologous series. Answer. A group of organic compounds containing same functional group represented by same general formula and exhibiting more or less similar trends in their properties is known as homologous series. Characteristics exhibited by homologous series are: first, every succeeding member differs from the previous one by CH2 group or by 14 atomic mass unit, that is, their molecular weight differs by 14 units. Second, they have the same functional group, hence their chemical properties show close resemblance. Third, the general formula of all compounds in a series is the same. Fourth, the physical properties of the compound show a gradual change with increase in molecular mass. Fifth, example of homologous series. A. Alkanes have general formula CnH2n plus 2. B. Alkenes having general formula CnH2n. Examples of compounds in the homologous series of alkenes are methane CH4, ethane C2H6, propane C3H8, butane C4H10, etc. Question 4. Differentiate between first, detergents and soaps. 1. Detergents are ammonium or sulfonate salts of long-chain carboxylic acid, whereas soaps are sodium or potassium salts of higher fatty acids. 2. Detergents are effective in hard water, whereas soaps get wasted in hard water. 3. Detergents are generally used to make shampoos and products for cleaning clothes, whereas soaps are used to make toilet soaps and laundry soaps. Question 5. Answer the following. First, draw chain and ring structures of organic compounds having 6 carbon atoms in them. Answer. The structure of the carbon compounds having 6 carbon atoms is given below. A. Cyclic or ring structure. For example, cyclohexane, that is C6H12, and benzene, that is C6H6. B. Open or linear unbranched structure. For example, hexane. C. Linear branched structure. First, for example, 2,2,3-methylpentane, 2-methylpentane, 2,2-dimethyl-1-butane. Second, which organic compounds are named as alkanol in IUPAC system? Answer. The alcohols with functional group OH are named as alkanol in IUPAC system. Third, explain what do you understand by substitution reaction? Answer. Reactions where one or more atoms in a molecule are replaced by another atom are called substitution reactions. For example, when methane is exposed to UV rays, that is ultraviolet rays, in the presence of chlorine, it forms methyl chloride as shown below. CH4 plus Cl2 when exposed to ultraviolet rays gives CH3Cl plus HCl. Fourth, which organic compound readily undergoes addition reactions? Why? Answer. Unsaturated organic compounds, example alkenes, alkynes, readily undergo addition reactions as they have double or triple bond between carbon atoms. For example, C double bond C and C triple bond C. Fifth, state and explain how are alkanes further classified. Answer. Alkanes have the general formula CnH2n plus 2. They are structural aliphatic hydrocarbons which can be linear or cyclic in structure. The linear and cyclic structure can be branched or unbranched. Based on these molecular structures, alkanes are further classified. For example, take the compound pentane having formula C5H12. The compound is classified on the basis of its structure, that is, whether it is an open chain or branched chain as shown below. First, pentane, CH3, CH2, 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 CH3. Second, 1-methyl-butane, CH3, CH, CH3, CH2, CH3. Third, 1,1-dimethyl 1-butane. CH3, C, CH3, CH3, CH2, CH3. Hexane can be a ring structure called cyclohexane or a linear structure which can be branched or unbranched. Sixth, state and explain how alkanes are further classified. Answer. First, organic compounds having covalent bonds. Example A. Ethyl chloride. B. Methane. Second, compounds having ionic bonds. Example A. Sodium chloride, that is NaCl, and B. Copper sulfate, that is CuSO4. Seventh, what are alkynes? Name the first member of alkyne family. Answer. Alkynes are hydrocarbons in which carbon-carbon atoms are linked by triple bonds. The first member of alkyne family is ethyne, that is ethine, that is CH triple bond CH or C2H2.